Now example 5.6. A block of mass m equal to 1 kilogram moving on a horizontal surface with speed v equal to 2 meter per second enter a rough page ranging from x equal to 0.1 meter. The retarding force F on the block in this range is inversely proportional to x over this range. F equal to minus k by x for 0.1 less than x less than 2.01 meter. It implies that here the retarding force that is acting only in this particular range starting from 0.1 meter to 2.01 meter. After 2.01 meter there is no retarding force, and before 0.1 meter there is no retarding force. So retarding force that is only in this particular range of the patch. So F equal to 0 for x less than 0.1 meter and x greater than 2.01 meter, where K that is 0.5 joule. Then what is the final kinetic energy and speed of the block as it crosses this patch that we have to find. Okay. Now we already discussed the work energy theorem for variable force. So we can write the change in kinetic energy K final minus K initial, that is equal to integration xi to xf f dx. Now here substitute the value of f that is minus k by x. So here if we take minus k, that is outside the integration because it is constant thing, and now we have to take integration of 1 upon x dx. Here ki that is taken on right hand side because that we can calculate easily, because mass of the block and initial velocity of the block that is given to you. Okay, so we can calculate initial kinetic energy. Now here integration of 1 upon x dx, that is equal to ln x. So ln x, that is the natural log of x, right? Natural log means log at the base of e. So ki that is half mvi square minus k integration 1 upon x dx, that is ln x, and limits are 0.1 lower limit and 2.01 upper limit. Now substitute the limits here. First x equal to upper limit, so ln 2.01 minus x equal to lower limit, so ln 0.1. But log x minus log y, that is equal to log x upon y. So we can write now here minus k ln 2.01 upon 0.1, and here substitute mass m equal to 1 kilogram and vi that is 2 meter per second. Okay. Now if we solve this one, then we will get here 1 2 cancel and another 2 will give you answer 2 joule, that is initial kinetic energy. Then k that is 0.5, ln 2.01 upon 0.1, so that is 20.1, so ln 20.1. Okay. Now natural log, e base log, right? So if you want to convert it in 10 base log, then there is the multiplication factor for that, that is 2.303. So here take the factor 2.303, then you can write this natural log as simple 10 base log, log 20.1. Now from the logarithmic table find out the log of 20.1, so that is of 20 and 1, and that is 1.3031. So now here we can write this is equal to 2 minus 0.5 into the factor 2.303 into log 20.1, that is 1.3031. Clear? So if we solve this one, then we will get final kinetic energy, that is 2 minus 1.5, that is 0.5 joule. Now once we have final kinetic energy, then easily we can calculate the final speed also, because final kinetic energy, that is half mvf square, where vf, that is the final velocity. Okay, so kf equal to half mvf square. Now substitute here kf, that is 0.5, mass, that is 1 kilogram, and make vf as a subject of equation. So vf, that is under root 2 kf by m, to kf, that is 0.5, m, that is 1. So you will get final velocity vf, that is 1 meter per second. Clear?